Hello students, hope you are fine and safe. Thank you for joining today's session, and today we will be learning about chemistry's topic, that is Lewis diagrams. Lewis diagrams are very useful in understanding the chemical bonding, and hence it has a lot of applications. So before jumping to today's objective, I must remind you that if you are interested in chemistry or any science topic, mathematics and coding, don't forget to subscribe my channel and ask me your doubt, or I will promise that I will clarify your doubt as soon as possible. So, jumping to today's topic. Today's topic is we will be learning about the Lewis diagrams, how to draw Lewis diagrams for atoms, for molecules, and we will discover some very useful patterns that facilitates the chemical bonding. So let's zoom in. So let's start with a simple question. How many valence electrons does chlorine have? So you have various options like 0, 6, 5, and 7. So think about that. Think about the periodic table where chlorine lies, and that will give a clue of how many valence electrons does chlorine have. Giving you more hints, valence electrons are the electrons that are present in the outermost shell. And the correct answer is 7. I'm sure that you have answered it correctly, and you must have used the knowledge of the periodic table. So let's have a look on the periodic table. So periodic table is a set of where is a place where we place their different elements, and they have the vertical columns, columns which we call it as groups. And based on these numbers, we can identify how many valence electron an element has. Now, you can easily identify the chlorine here because it has 7 valence electron. That means it's placed in the 7th group. Similarly, we have to understand this picture and we have to remember it as well for solving the diagram. Now, let's remember the basic things for Lewis diagram. In Lewis diagram, we use the dots to represent the valence electron. That means that you have to know the number of valence electron, which in turn requires the knowledge of this periodic table. So this is very important, students. Now, take an example of the same element, that is chlorine. You told that the chlorine has 7 valence electrons, right? Now we can see that 7, how we can write it. So for Lewis diagram, as you know that we put dots beside it, so we can say that the chlorine has 7 valence electrons. So with 7 valence electrons are denoted in the form of dots. Now students, you have to remember that your Lewis diagram should be neat. That means you can add an imaginary square around the particular element, and you can put the valence electron around the sides of the square. Just remember that you cannot add more than 2 dots on each side of the square. That's very important. You cannot put 3. You are most welcome to put 1, but you cannot put 3. Let's proceed to a second example, which is hydrogen. Now, from this picture, it's clear that hydrogen has 1 valence electron, right? So we can write hydrogen, the symbol of hydrogen element, and then we can simply write 1 valence electron. So the dot represents the valence electron, not the total electrons. Similarly, the Lewis diagram of carbon, you can identify carbon here. So carbon has 4 valence electrons, right? So we can write the symbol of carbon, and we can simply write the 4 dots as the 4 valence electrons around the symbol of carbon. Similarly, the Lewis diagram of oxygen, if you can identify oxygen is right here, and it has 6 valence electrons, right? And so we can write the symbol of oxygen, and we can write the electrons for the 6 valence electrons in the form of dots. So just remember, I'm reminding you that we cannot put more than 2 dots on one side of the square. And your Lewis diagram should be very neat. Now, let's discuss the basic applications of Lewis diagram.
Lewis diagrams are used to represent the covalent bonding in molecules and ions. Now, students, let me remind you, the covalent bonding is a bonding where there is a sharing of electrons takes place, right? So, in covalent bonding, as I told, that the atoms share the valence electron, and most importantly, why they share and how much they share. So, they want to fulfill their octet. If you remember that I have shared one video previously on intra and intermolecular forces, and there I have discussed about the octet and the duet rule. If you have missed that video, you can visit the description of this video and you can find the link right there. So please visit that video to understand what is an octet rule and what is a duet rule. Now coming back here, duet rule is applied only for hydrogen and helium. Duet means two electrons, two valence electrons. So only hydrogen and helium wants to achieve two valence electrons. And other than that, every other element wants to achieve 8 electrons in their outermost shell. In other words, octet. Okay. Now, we have to remember this periodic table as told by you. And for example, if we want to draw the Lewis diagram of hydrogen molecule, that means H2. That means we can write one hydrogen atom with one valence electron and the second hydrogen atom as the second valence electron. That means this is the valence electron of the second hydrogen atom. And here we can write it like this. And remember that in this example, hydrogen satisfies its duet. Similarly, we can also understand that shared electrons are counted as owned by both the atoms. What does it mean? That means if hydrogen shares the electron of the other hydrogen atom, that means these two electrons are equally counted by each hydrogen atom. Okay. Now, both the hydrogen atoms here are happy because they're sharing the electrons and they are fulfilling their duet. But bonded electrons versus lone pair of electrons. Students, these terms are very, very important for understanding the Lewis diagram. So please pay attention. Bonded electrons are represented by lines. Okay, so that's a basic difference. So whenever we form a bond, that means they have a set of electrons. We'll discuss how many. And lone pair of electrons doesn't have lines. Okay, so for example, just we did it, this hydrogen molecule. So these two electrons are shared by two hydrogen atoms. That means that these two electrons can be represented by a single line. That means they are bonded, right? So that is a bonded electron. Now coming to non-bonding, what are the non-bonding electrons? They are denoted by dots. Okay, so they are also called as lone pair of electrons. That means the electrons that are not shared and are extras, they are called the lone pair of electrons. Remember the word pair. Remember a pair of shoes. That means what? Two shoes, but they exist in one pair, right? Similarly, here, whenever I'm telling lone pair of electrons, I'm referring to two electrons. Okay, now let's understand some basic rules which we need to remember while drawing the Lewis diagram. So the first line, or if we draw a single line, that means it's a single bond and which represents two electrons. If we draw two lines, that means it's a double bond, represents 4 electrons, right? Two dots are called lone pair of electrons. That means not involved in bonding. 3 lines, on the other hand, is triple bond and it has 6 electrons. Now take the example of single bond. Single bond is one line. That means it has 2 electrons. So the number of bonding electrons is 2, right? It has no lone pair of electrons here. Now coming to oxygen. If you remember, oxygen has a valency of 6. So we can write the electrons, right? So 1, 2, 3, 4, 5, and 6. So it has 6 electrons. Similarly, if it wants to form an oxygen molecule like O2, that means the other oxygen atom will also have 6 electrons. So we can write the 6 electrons of the other oxygen atom like this. And hence you can see that the 2 electrons each will form a single bond. That means the 2 single bond becomes here a double bond. That the lines represent the bonded pairs of electrons, and while the electrons which are represented as dots, they are called the lone pair of electrons. Okay, here we can see that the lone pairs are not shared with the other atom, they are free. So these are lone pairs of electrons. Now we can take a third example of nitrogen. Nitrogen has a valency of 5. You can refer to a periodic table and you can understand that nitrogen has a valency of 5. Hence we can write 5 electrons or 5 dots, right? Like this. Now, if you take another nitrogen atom, of course, that will also have a 5 valence electron. And here what happens for the nitrogen, they share, the 2 nitrogen atoms share the 3 electrons with each other. That means we can say that it forms a triple bond. That means they share 6 electrons. Okay, so most importantly, if you can notice here, all the atom, that is oxygen and nitrogen, they satisfy the object of each valence electron in their outermost shell, while hydrogen satisfies only is duet because it has only 2 electrons in its outermost shell. Now, students, over to you. Let me see how far you have understood. State the number of electrons involved in a double bond. So here is an example of double bond of O, double bond O. You have to state the number of electrons involved in the bond formation, that is double bond, right? Your options are 1, 2, 3, and 4. Students, every one of you must participate. Please write the correct answer in the chat. I'm sure that you are trying your best and you have answered it correctly, and the correct answer is 4. Why? Because each line means 2 electrons, right? So since they're a double bond, that means they are sharing 2 plus 2, that is 4 electrons. Well done, students. Very nice. Next question. State the number of lone pair of electrons. So let me remind you, lone pair of electrons are the electrons which are not involved in bonding. So you have to state the number of lone pair of electrons. Focusing on the word pair, and each fluorine atom has in fluorine molecule. So this is a fluorine molecule. You have to guess the right answer for the number of lone pairs of electrons in each fluorine atom. So one fluorine atom has how many lone pairs of electrons? Your options are 2, 3, 1, and 6. Write down the answer in the chat. Students, I'm sure that you are trying your best. Please keep on trying and participate. I am sure that you have answered it correctly. And the correct answer is 3. Why 3? It is lone pair of electrons. Though the total number of electrons which are not involved in bonding is 6, but whenever we use the term lone pair, that means we have to understand that they are pairs of electrons. That means the 1 plus 1 plus 1, that is 3 pairs of lone pair of electrons. Okay, well done. Awesome, students. Wonderful. Students, let's now discuss the Lewis diagram of more molecules. Let's take the example of simple molecule like water. Now, before understanding how to draw the Lewis diagram, we must take into our account how to draw, or what are the basic steps of drawing the Lewis diagram. So here the first step is we have to count the number of valence electron. So here, for example, here we have H2O. That means we need to calculate the valence electron of both hydrogen, that is 2 hydrogens and 1 oxygen. Now, if you see here, we have calculated the total valence of electron as H2 as 1 times 2 and the oxygen as the 6 times 1, that is 6. Now coming to the next rule, which is determine the central atom. So here it is very important, students. Central atom is the atom which is less in number. So for example, in this case of water, so if there are two hydrogen, that is hydrogen number is 2 and oxygen number is only 1, that means oxygen is less in number, right? And hence we can understand that oxygen should be the central atom, right? And this is the thing that we have to follow while drawing every Lewis diagrams. Now, the third important step is that we have to draw single bonds to the central atom. I will show you how. At the second last step is we'll put all the remaining valence electrons as lone pairs of electrons. And finally, we will turn the lone pairs into double bonds or triple bonds. Okay. To that, while understanding or while putting the double or the triple bond, we must keep into mind, students, that they satisfy the duet or the octet, depending on the element. Now let's take this example. So we have already calculated the total valence electron for water as 8. And as the second step here is the central atom, right? So we have to understand which one is the central atom. As I told, that oxygen is the central atom in this case. Why? It is because it is smaller in number. So we have written like this. And third step is draw single bonds to the central atom. So we have drawn already the single bond from the central atom, right? Now, fourth step is put all the remaining valence electrons on atoms as lone pairs. So what is the remaining atom, students? So how many atoms are, how many electrons are involved in bonding here? You can see, you can understand that there's two single bonds. That means 2 plus 2 what? It is 4. 4 electrons are involved in bonding. That means remaining electrons is 8 minus 4, that is 4. So remaining 4 electrons we have to write as lone pairs of electrons. We cannot write the lone pairs on hydrogen because hydrogen has already satisfied its duet. It cannot accommodate more than 2 electrons, right? Even after sharing. So we have to accommodate the lone pair of electrons on the top of oxygen. So here we have to check the last step, very important, students, that all the atoms, whether it is hydrogen or oxygen in this case, they should satisfy the octet or duet. Now let's check. Hydrogen has already satisfied its duet. Now coming to oxygen, if you check, there are two lone pairs. That means there are 4 electrons, and the 2 bonds, that means 4 electrons. That means 4 plus 4 is 8. That means oxygen satisfies its octet. So here, this is how we'll do. Let's take a second example of carbon dioxide. So we'll keep these steps into mind. So let's first calculate and understand the number of valence electrons for both carbon and oxygen, right? So total valence electrons, if you can identify here, carbon is 4 and number of carbon is only 1. So we can write 1 times 4 as 4. Similarly for oxygen has valence electron of 6. So we can write, and since there are 2 oxygen atoms, so we can write 2 times 6 is 12. Total valence electrons becomes 12 plus 4. That means 16. And second step is we have to determine the central atom. Central atom is the atom which is lower in or smaller in number. So we can write carbon in the middle and oxygen on the 2 sides, right? And simply we'll draw the third step. That means we'll draw single bonds to the central atom. So this is the third step. Now, fourth step is we have to calculate the remaining electrons or valence electrons which are not involved in the bonding process. Now, coming to this calculation, so used bonds is 2 plus 2, that is 4. So remaining will be what? 16 minus 4, which is equal to 12. So we have to accommodate 12 electrons around these two. So now let's accommodate this 2, 2 plus 2, 4, plus 2, 6, plus 2, 8, plus 8, 10, and 12. So we have accommodated 12 electrons. Now let's check the last step. That means every atom should satisfy the duet or the octet. Here, no chance of duet because hydrogen and helium is not involved. So we have to check the octet. So let's check. Oxygen, if you can check, it satisfies its octet because 2 plus 2 plus 2 plus here 2. The bonding electron is also 2. So oxygen on both sides satisfies its octet. Oxygen, happy. Carbon, coming to carbon. How many carbon has it now? If you can check, carbon has only 2 plus 2, that is 4 electrons. Carbon is not happy. Carbon wants to achieve octet. So what will it do? Now there will be a formation of double bond. So shifting of electrons will take place here, as you can see. And now here, each extra electrons will form a double bond. Okay. So here we can now check, verify. You can see that carbon satisfies its octet as well as oxygen. Okay. Remember that that's last step. We have to verify whether the elements satisfies the duet or the octet. So here carbon and oxygen have 8 valence electrons. Let's jump to the next question. It is oxygen fluoride, that is OF2. Now, OF2 is which elements are involved? Oxygen and fluorine. Let's check the valence electrons. For oxygen, it is 6, and for fluorine, it is 7. Now, let's check the total valence electrons. For oxygen, it is only 1 oxygen, so we can write 1 times 6 is 6. For fluorine, we can write 2 times 7, that is 14. Total valence electrons becomes 14 plus 6, that is 20, right? And then we have to determine the central atom. Central atom, which you can guess now because it is only 1 in number. So oxygen should be the central atom. And we can write a 2 fluorine on the 2 sides. Now let's join the single bonds. That's the third step. So let's join the third step. What is the fourth step? We have to calculate the remaining electrons. So how many electrons are already involved in bonding? It is 2 plus 2, that is 4. Now simply we will write used in bonds is 4 and total remaining is 16. So we have to accommodate 16 electrons across these atoms. Now let's check here. We are arranging the 16 electrons, and here we have already accommodated 3 plus 3, 6, that is 12. And here we can write the remaining. Okay, now the last step. Last step is we have to check whether each element is satisfying its octet or duet. So here you can check here that all the chlorine as well as oxygen satisfies the octet. Hence, it is the perfect one. We need not shift any electrons here to form double or triple bond, and hence this is the final Lewis structure. Okay, students, please verify that oxygen and fluorine have 8 valence electrons. Now let's move to the fourth example. It's the methane, that is CH4. So you must have now understood the first step. We have to do what? We have to see where carbon lies. And carbon lies here in the fourth group, right? And here we can see that it has 4 valence electrons, and 4 hydrogens have also 4 times 1, that is 4 electrons. And this in turn shows us that it has total of 8 electrons, right? Now the central atom will be carbon because carbon is less in number, and we can accommodate the 4 hydrogen like this. Now we'll draw the third step, that is single bonds. So we can draw the single bonds, or we can simply draw the 2 electrons, because we know that each single bond means there is 2 electrons are involved. So the used electrons in the bonds is 8. So simply you can write with the difference, that is remaining is 0, right? And hence there will be no lone pair of electrons, absolutely no lone pair of electrons in carbon in this example. And you can check the last step, that each element satisfies the duet or the octet. Hydrogen satisfies the duet, carbon satisfies the octet, and so on. So that last step is also verified. And hence this is the final Lewis structure of methane. This is the methane's Lewis structure. Okay. Let's move to the final example that I want to share in this video, that is sulfur trioxide. Now this example, student, is an exception, and hence I have chosen this example for you. So, but initial few steps will be same. So it is sulfur and oxygen, right? So from the periodic table, you can see that sulfur should have 6 valence electrons. So if we can write total valence electrons, that means 1 sulfur is involved, that is 1 times 6 is 6. Similarly, there are 3 oxygen atoms involved, that is 6 times 3 is 18. And total valence electrons becomes 24, right? And here the central atom will be sulfur. Why? Because sulfur is less in number. So we can write sulfur and the 3 oxygen like this. What is the third step? We have to draw a single bond. So instead of single bond, you can also write 2 dots or 2 electrons. Now, let's calculate the number of valence electrons. So, used in bonds is 6. So, total lone pairs of electrons should be 18, right? So, we have to accommodate these 18 electrons across all the elements here. So, let's now arrange the 18 electrons. So, here you can see that 3 times 2 is 6 electrons are involved. Similarly, here is also 12, total 12, and now here also it is 18. So 6 times 3 is 18. 18 electrons are satisfied. Now, the last on final step, that's a very important step, students, that we have to check or verify whether sulfur and oxygen have 8 valence electrons or not. Now, it is very clear that oxygen, all the oxygen satisfies its octet, but not sulfur. Sulfur has only 2 plus 2, 4, plus 2, 6 electrons in its outermost shell, and it is not happy, obviously. So we have to make a rearrangement. Now, if once oxygen atom rearranges it, it forms a double bond. That much is quite expected. Now, students, why this example is important? This example is important because sulfur here can accommodate more than 8 electrons. So it deviates the octet. It's an exception. So you can see that the 3 oxygen shares another pair of electrons with sulfur, and oxygen forms a double bond with sulfur. So that's very important, students. We have to understand and remember that in this particular sulfur trioxide example, here oxygen will form double bond with sulfur. That's a pattern, but here sulfur deviates the octet. So I have chosen this example particularly for you, while but rest all others compounds, you should find that it will, or every element should satisfy its octet. Okay. Now, based on these examples, I want you to understand or guess some basic patterns of these atoms. That means, let's start with the first example of fluorine. Okay, so fluorine, all these elements or all these molecules of fluorine, this is hydrogen fluoride, this is fluorine molecule F2, this is xenon tetrafluoride, this is oxyfluoride. So now these all elements of fluorine, how many bonds can one fluorine make? That's the question. I'm repeating the question. How many bonds can one fluorine atom make? So here also a fluorine atom is there. Here also fluorine atom is there. Here also the fluorine atom is there. How many bonds can one fluorine make? Write the answer in the chat. Students, you need to participate, because while we participate, that means we are confident, right? And we will perform better in our exam. So I will encourage you to please participate. And I'm sure that you have answered correctly, and answer is 1. You can understand it clearly that here it is the fluorine is making 1 bond, right? 2 electrons means it's 1 bond. Here also it's making a single bond, and here also fluorine is making a single bond, and here also it's making a single bond. Fluorine is making a single bond. Now students, remember every halogen, whether it is fluorine, whether it is chlorine, bromine or iodine, they form single bonds. So this is a tip that I want to give you for your examination. And similarly, I want you to write the answer in the chat of the second question. How many lone pairs does each fluorine atom have? So understand the question, read the question carefully, and write the answer to this given question. How many lone pairs of electron does each fluorine atom have? So for example, if you take this fluorine atom, how many lone pairs it has? Write down the answer in the chat. I'm sure that you've answered it correctly, and it is 3. Because every fluorine atom you have seen here, it has 3 fluorine atom, 3 lone pairs of electrons. Now coming to the molecules of oxygen. So oxygen also have some pattern. So just like the previously, why am I discussing this pattern? Because this pattern will help you to predict the Lewis diagram of an unknown molecule. So for example, if any unknown molecule is there and there is a fluorine in it, or it has an oxygen or some is in it, then you can understand, okay, fluorine makes a single bond, so I cannot make fluorine a double bond. So that for that reason, I want this discussion with you on the patterns, on guessing the patterns. Just like fluorine, oxygen also develops some pattern. Now, can you guess how many bonds does each oxygen make? So please have a look. Please notice these molecules of oxygen very carefully. This is water. This is H2O. And this is carbon dioxide. This is sulfur trioxide. And this is simple oxygen molecule, that is O2. Now, there is a common pattern between all these molecules of oxygen. And here, the how many bonds does each oxygen make? That's the question. Write down the answer in the chat. Please participate, students. Write down the answer in the chat. I'm sure that you have answered it correctly. Okay, so the correct answer is 2. It's very clear from these diagrams that here the oxygen makes 2 single bonds, but it can finally make 2 bonds, not 3, not 1. And similarly, here also single oxygen atom can make a double bond, but the total number of bonds is 2. Similarly, here also it is 2, and in sulfur trioxide, each oxygen atom can make 2 bonds. It is not 1 bond or it is not 3 bonds. Okay. Similarly, can you write down in the chat how many lone pairs does each oxygen atom have? Please write down the answer in the chat. Come on, let me see. How many lone pairs of electrons? Lone pairs of electrons are the electrons which are not involved in the bonding. Okay. So count the number of lone pairs of electrons, not the total electrons, that are not involved in the bonding. I'm sure that you've answered it correctly, and it is 2. Now you can see here for each oxygen atom, there are 2 sets of electrons or 2 pairs of electrons which are not involved in bonding, and that is the lone pair of electrons. Okay. Coming to the third question, or the pattern, understanding the patterns of nitrogen. So here I have given you 3 examples of molecules which have nitrogen. Now also the nitrogen have a common pattern, and this you will, I'm sure that you will answer it correctly. How many bonds do nitrogen make? Write the answer in the chat. How many bonds do nitrogen make? So look and carefully investigate each molecule. Nitrogen has how many bonds? Okay, so I'm sure that you have answered correctly now. It is 3, right? Here we can see that each nitrogen or one nitrogen atom is there. It is hydrogen cyanide and it has 3 bonds possible. 3, we call it as triple bond. Here also the nitrogen molecule, that is N2, it has a triple bond. Here also it is no triple bond but maximum 3 single bonds. So total 3 bonds is possible, isn't it? Now, same question I want to repeat. How many lone pairs does each nitrogen have? Count the number of lone pairs of each nitrogen atom and write the answer in the chat. How many lone pairs of electron does each nitrogen have? I'm sure that you have answered it correctly, and it is 1. It is clearly visible. Each nitrogen atom has only 1 lone pair of electrons. 1 lone pair means it is a 2 electrons. But whenever I ask that lone pair, that means you have to answer it as 1 lone pair of electrons. Okay, wonderful students. Thank you for your participation. Well done. Coming to the last part, which is the molecule of carbon. It is also a pattern. Okay, so now if you investigate into these molecules like hydrogen cyanide, it is carbon dioxide, it is CH4, which is methane, and it is CCl4, which is carbon tetrachloride. Now, can you investigate a common pattern of these carbon molecules as well? How many bonds do carbon make? Write down the correct answer in the chat. How many bonds do carbon make in these compounds? Write down the answer in the chat. I'm sure that you have answered it correctly. It is 4. So where it is, for example, for the hydrogen cyanide, it is one side it is triple bond and one side it is single bond, but the total number of bonds should be 4. For this carbon dioxide, there are 2 double bonds is there, but the total number of bonds is 4. For methane, it is 4 single bonds. And for carbon tetrachloride, it is also 4 single bonds. Okay, so whatever be the case, it will form, carbon will form maximum 4 bonds. Remember the pattern. Now, how many lone pairs does each carbon have? Write down the answer in the chat. How many lone pairs does each carbon have? Write down the answer in the chat. I'm sure, 100% that you have answered it correctly, and it is zero because carbon doesn't have any lone pair of electrons in these examples, and also in any examples, carbon cannot have a lone pair of electrons here, right? So the answer is zero. So all these patterns, students, we have learned why? Because we can apply these patterns into any unknown molecule.
So students, we have come to an end of our today's session. I hope that you have the basic concept on how to draw Lewis diagrams of molecules and simple as well as some complex molecules. Don't forget to attempt this homework question and write the answer in the comments down below. Don't forget to ask your doubts. I promise, as I have before, that I will clarify your doubt as soon as possible. So, take care. Goodbye.